Chapter 10. So we are now in the second portion of the course. In this portion of the course, we will focus on graphing and analyzing data. These are the concepts we will discuss in Chapter 10. Data tables, pie charts, bar graphs, and line graphs. In particular, we will discuss the purpose of these graphs and how they are properly constructed. First of all, why should we use a graph when studying data? Simply put, graphs allow us to summarize data so as to understand its key features without having to look at each individual observation in the data set. Some examples of things we might be able to quickly discern using a graph are the spread and the center of the data. In other words, we might ask questions like, are the observations concentrated around a particular value? What is the smallest value? What is the largest value? And so on. Now, before a data set makes its way into a graph, it's often stated in a table first. Tables are often used to summarize the information in a data set. Oftentimes, we don't need to know the information on every single individual. We just need to know the counts and the categories that are of interest to us. So what exactly makes a clear table? First, it needs to be clearly labeled so that we can see the subject of the data. The main heading describes the general subject of the data and also gives the date because these data will change over time. Labels must be used within the table to identify the variables and state the units in which they are measured. Finally, the source of the data needs to appear at the foot of the table. Let's look at an example of a table that is properly stated and labeled. First, the title is clearly labeled. This is Table 10.1, and the main heading and date appear across the top. Notice how we can quickly discern the purpose of the table without any additional context. Next, labels are given for each variable of interest and units are provided where appropriate. Finally, the source for the information in the table appears across the footer. Let's now discuss a concept that will be very important for our course. In the previous example, the table listed the education level of people aged 25 years and over. So in this case, the individuals were those 25 and over, and the variable of interest was their level of education. The table listed the values this variable could take, for example, high school graduate, bachelor's degree, etc., and also how often each of these values were taken. In this case, we'd say that the table tells us the distribution of this variable. In general, the distribution of a variable tells us what values a variable can take and how often it takes them. Now, sometimes round-off errors occur when distributions are presented in a table, due to trying to keep the presentation simpler. If we know the distribution of a variable, we can make what's called a pie chart. A pie chart shows the proportion each value is taken by representing each as a wedge of a circle. To construct a pie chart, first draw a circle. Then, break up the circle into wedges where the angle of each wedge corresponds to each proportion. For example, let's make a pie chart for the previous table. Here the variable can take one of 6 values, so the chart will have 6 wedges. In particular, high school grad will be the largest wedge, as it is the largest proportion, and associate's degree will be the smallest. There are 2 downsides of using a pie chart to represent data, though. First, it can only be used when the distribution is known. Second, comparing proportions with angles can be at times a bit difficult to read. For instance, it would be difficult to quickly rank the proportions of each category in the pie chart below if the actual numbers were not written near each wedge. Because of this, anytime we'd use a pie chart, we'd more than likely use a bar graph. In a bar graph, each proportion is represented by the height of a rectangle rather than an angle. Now, before we discuss other means of graphing data, we need to distinguish between variables whose value have a meaningful numerical scale and those which simply place individuals into categories. A categorical variable places an individual into one of several groups or categories. A quantitative variable takes numerical values for which the operations of arithmetic make sense. In general, when working with a categorical variable, use a pie chart or a bar graph to display the distribution. Let's look at an example from your book. Figure 10.4 compares the level of taxation in 8 democratic nations. The heights of the bars show percentages of each nation's GDP that come from taxes. One thing to note from this example is that a pie chart could not be used for this purpose, as we are simply comparing quantities, and these quantities do not make up some meaningful whole. Now you try one. The Retirement Living Information Center compiled data on combined state and local taxes as a percentage of total income for a family of 3 earning $50,000 in the largest city in each of the 50 states for 2009. The table below gives the values for some selected Midwestern states. Is the variable state categorical or quantitative? Also, to show the distribution of these data, would you use a pie chart or a bar graph? So pause the video and unpause when you're ready for the answer. In this example, state is what we would call a categorical variable. To show the distribution of these data, we would use a bar graph, as we are simply comparing quantities, and these quantities do not make up a meaningful whole. In particular, your bar graph would look something like this. Sometimes we want to study how certain quantitative variables change over time. In this case, we will often construct what's called a line graph. A line graph of a variable plots each observation against the time at which it was measured. Time will always go on the horizontal scale, and the variable we are measuring goes on the vertical scale. Finally, after plotting all the data points, connect adjacent pairs of points with a straight line. When studying a line graph, we will look for the following items. First, an overall pattern. For example, a trend is a long-term upward or downward movement over time. Next, deviations from this overall pattern or trend. Finally, we'll look for seasonal variation, which is a pattern that repeats itself at known regular intervals every year. For example, suppose you are in charge of tracking sales at a candy company. Whether or not the company gains or loses money every year can be determined by the trend of the line graph. Furthermore, during holidays you may observe some seasonal variation that you may adjust for when considering the overall trend. Now you try one. The U.S. Department of Agriculture provides data on the monthly average price of a gallon of milk. The table below gives values for January 2010 through December 2011. Make a line graph of these data and comment on any patterns you observe. Remember that time goes on the x-axis, so price will be displayed on the y-axis. So pause the video and unpause when you're ready for the answer. Your graph should show an upward trend like this one. As far as seasonal behavior is concerned, there seems to be a sharp change in the price near the beginning of each new year. In closing, let's summarize some items that are good to consider when creating an effective graph. First, make sure labels and legends tell what variables are plotted, their units, and the source of the data. Next, make sure the data stands out, rather than the other elements of the graph. Finally, don't oversaturate the graph with images and effects. Although it is fine to make something that is aesthetically pleasing, the visual appeal should never be the main focus. Rather, our focus should be to convey the characteristics of the data in the clearest way possible.